is that currently a lot of very clever people with spare time on their hands are looking at using Arduino to design and build ventilators for helping with this pandemic. Now, they're not perfect quality, but I find it amazing that this tiny little computer board, which is essentially just a couple of chips, is out there able to save lives. So I thought Arduino would be a great thing to look at today. Now, for this, we're going to have to use something called Tinkercad. So if you go to the website address www.tinkercad, all one word, .com/join class, then it'll give you a code to type in. And that code should be this one here. ZT9CWRMXNFMT. If it doesn't work, that's fine. You can access Tinkercad by making your own account. But if you type in this code, you shouldn't need to make an account. It's free anyway. So let me type that in here. ZT9CWRMXNFMT. So to recap, all I've done is I've gone to the website www.tinkercad.com and I have gone to join class. So yeah, so just /join class, and there we are. Okay, now when you click go to my class, it allows you to put in a nickname. Now there's 50 available nicknames, and it has to be one of these. So it's going to be Technoclub followed by a number, and those numbers are 1 to 50. And you need to choose whichever number, 1 to 50, to go after Technoclub. If it doesn't work, that means someone else has chosen that number. Okay, let's try Technoclub 15. And there we are, that one's worked. And now you're into Tinkercad. You're right there. There's your account. But we've got several options. We can make a 3D design, a circuit, some code blocks or lessons. We want to make a circuit. So if you click on the left into circuits, we can create new circuit. And instead of getting an Arduino up, I'm going to get a 9-volt battery. Actually, let's not get a 9-volt battery. That's a little bit too powerful. My mistake. Let's get a coin cell battery. So if you can't find it, you can search in this search box, coin cell, there we are, coin cell battery. And I click on it once, and then when I move my mouse over to the left, it turns up for me. And once I click and click again, when I click it places it, when I click off it deselects it. So this is our coin cell battery. It has 3 volts of energy. We've got a positive connection and we've got a negative connection. Well, what can we do with this? Let's make the most basic circuit we can think of. So I'm going to clear this search. I'm going to get an LED. Okay, so I'm just going to place my LED down. Now I want this LED to light up. It's a light bulb. So let's grab the positive lead, and when I click on it, you can see it's drawing with a green line. This is our wire. So just any kind of wire, kind of wire that goes in the back of your PC, anything like that. But this is our single wire for the positive, and every time I click, it puts a new bend in the wire for us. It doesn't change what the wire does, it just makes it easier to make things neat and tidy. If I've made a mistake and I've made too many bends, I can press backspace on my computer and it deletes each of the bends that I've added. Let's turn this LED around. So to rotate things in Tinkercad, you click on it, so it has a blue outline. That's selected now. And then, up in the very top left, you see this little 2 triangles button. And that's the rotate button. So if I press that, it rotates it around. There we are. I'm going to put it that way around. So let's try again with our connection. So positive now goes on to the anode. Let's make that red, that wire, just so I know what I'm working with. And let's have the negative come all the way along and up and on to the cathode. Let's make that black. Okay, so what's up here? Well, obviously my LED is not lighting, and that's because we haven't actually made it run yet. We haven't run the program. And to do that, we go ahead and click Start Simulation. And there we are, our LED lights up. But there's a problem. This little information symbol, if I hover over it, tells us that the current through the LED is 61 milliamps, which the recommended ampage for an LED is 20 milliamps. So basically I'm almost blowing up my LED. That's not good. So what do I need to do instead? Well, I need to limit the current somehow. So let's go ahead and stop simulation. The easiest way to limit current is with a resistor. So in the search box, I'm going to type in resistor. There we are. If I grab this resistor, let's plonk it in our circuit. So I'm going to stick that sideways, so make sure it's selected. Rotate, rotate, rotate. And now I can grab this and let's put that in line. So I'm going to remove my red wire from the LED, stick it on the end of the resistor, and I'm going to make a new wire from the resistor to the LED. Let's see if that works. Let's start simulation. And there we are. The LED is lit, but it's not exploding. If I click on the resistor, I can even change the resistance of it. So kilo ohm is quite a big resistance. Let's make it a small resistance. Obviously that's too much. Let's make that 100 ohms. Yeah, that works well. So I've got a lit LED. But where's the computery part of that? That's just circuits. That's boring. So let's spice this up a little. So I'm going to stop simulation, and rather than using a coin battery, which has only 2 modes, either on or off, I'm going to use a small little circuit board instead, an Arduino. So let's click the coin battery and press delete. And inside the search box, I'm going to search for an Arduino. And the one that we want is an Arduino Uno R3. So I'm going to click that, and I'm going to drag it in. Okay. Now let's work on this. So it's much easier to use the Arduino if you turn it 90 degrees sideways. So I'm going to click on it, I'm going to rotate it a little. Ooh, not that much. There we are, went for a little spin there. Let's get out of the way. Okay, so what do we need? Well, we need exactly the same as before. We need power going to the LED, and we also need negative going to the LED. Now, the negative on here is called ground, or GND. So let's delete that resistor. Let's turn our LED around so it's easier to work with. So we need to connect our ground to the right prong of the LED. So if you look on the left of the Arduino, see one of the pins is called GND, and when you hover over it, it tells you the name. I'm going to click it once, and that starts drawing a wire. And I'm going to connect it to my LED. Let's make that wire black so that we know it's the negative wire. Now what do we need? We need to connect to the... We need to connect up to the electricity again. So the one we want is the 5-volt pin. So if you look over on the left of the Arduino, you'll see one of the pins is labeled 5V. I'm going to click that, and that's going to start drawing a wire for me. So I'm going to have it down there, have it down there, have it down there, and then I'm going to have it connecting to the LED. And let's make that wire red so I know it's positive. So when I start simulation, I should have it that my LED lights up. Let's see. Oh, it does, but look at the current through it. It's currently running at 483 milliamps, and we can actually see that the LED has blown up. It's that much electricity is going through it, which obviously is a pretty bad thing. So we mustn't forget our resistor. So let me go into the search bar again. Let's find the resistor. I'm going to click it and I'm going to drag it in. And what I'm going to do is I'm going to put it between the LED and the positive. So click the positive wire. Let's drag that down or sort of replace the LED there. Sorry, put the resistor in the way. Then I'm going to get the other end of the resistor and plug it into the LED. So now that should stop it blowing up. Let's press start simulation to see. There we are. It doesn't blow up at all. So that's great, but I want to switch it off or switch it on or control it in some way. So these two pins, the 5-volt and the ground, are constantly... Sorry, the 5-volt is constantly receiving power. That's not great. I want it so that it only sends out power when I want it to. And for that I need to use a different pin. So I'm going to press stop simulation. And on the wire that goes from the 5-volt to the resistor, I'm going to click and I'm going to delete it. And instead, we want a wire that goes from one of these pins on the right, because we can control these. So let's choose, let's say, pin 4. Pin 4's nice and innocent, nothing wrong with pin 4. So I'm going to click pin 4, and I'm going to connect it to the resistor. I don't need to change the color. I mean, I never need to change the color anyway, but As it's not the 5-volt one, it shouldn't really be read. Okay. So what happens now when I press start simulation? The LED doesn't light. And that's because we've not given the Arduino any code to tell it to switch pin 4 on. So that's what we're going to do next. We're going to tell pin 4 to switch on. So let's press stop simulation. And we're going to go to this button in the top right called code. And when I click on code, you've got a coding window that is almost identical to Scratch. And this is where we can actually start controlling things. And it started by giving us 4 lines of code. These are useless to us. We don't need them. So I'm going to click on them once and drag them into the bin. There you are. What next? Well, what do I want? I want it so that it switches on pin 4 and then waits a little while, and then switches it off, and then switches it on, then switches it off, and so on and so on and so on and so on. So what we need is we need to grab this block in the left called set pin something to something. I'm going to drag that in and I'll explain the different options we have. So here we can select which pin that we're talking about. When we're talking about pin 4. So I'm going to select pin 4. Now in this option I've got an option between low and high. Low means that it's not sending out any electricity. It's sending out 0 volts. But high means it's sending out a lot of electricity. It's sending out I think 3.3 volts or 5 volts or something in that region. So we want that high. And what do we want to do after that? Well, we want to wait a little bit and then switch it off again. So I'm going to go to control. And in control, there's this option to wait however many seconds. I'm going to grab that and stick it in. What should we do after we've waited that many seconds? Well, we should switch it off again. So to do that, I go to output. I grab this block called set pin something to something. Stick it in there. We're talking about pin 4. So let me change that to pin 4. And if high means that the light is switched on, then low must mean it's switched off. So I'm going to change that to low. And then what do I want? I want it to wait another second. So in control, wait 1 second. But I want it to do this forever. Or 10 times, or however many times. So I need to repeat this. So I need to stick a repeat block around that. So let's stick this repeat 10 times. Let's just stick it around the whole thing. So now, what should happen is as soon as my Arduino turns on, it should make that LED blink on for a second, off for a second, on for a second, off for a second, on for a second, off for a second, and so on and so on and so on. Let's see. Let's press start simulation. Let's minimize the code. And there we are. My LED is blinking. That's brilliant. Let's make it a little bit more interesting. Let's click stop simulation. What happens if I want to change how fast it blinks? Well, how can I get some value into there so that the computer knows how fast it should be doing things? I need another input device. At the moment, there are no input devices on that board. I need something that's an input device. And the one that I'm going to use is a potentiometer. And what a potentiometer does is basically it's a dial. So if you ever use a radio and you turn the volume up or the volume down, if you're doing that with a dial that you turn, that you physically rotate with your hands, that's a potentiometer. And all a potentiometer is a special type of resistor that as you turn it up, the resistance gets higher, and as you turn it down, the resistance gets lower. So I'm going to click potentiometer and drag it in. And this is how we're going to get the values that the user wants. So you'll see that on the potentiometer there are 3 pins. And I need to connect these up to the right thing. So the left pin, the leftmost pin, is going to go to the power. So I'm going to click it, and I'm going to start drawing a wire that goes to the power. Because that's power, let's make it red. Righty-o-ty. And now, the rightmost pin, the pin number 3 on the right, I need that to go to the negative, to the ground. So let me draw that out. And let's stick it in the ground. Because that's ground, let's make that black to remind us. And the middle pin is where we get all the information. That's how we measure the resistance of the potentiometer at that time. And to do that, I'm going to have to do something called an analog read. So these pins down the right have only 2 options. They can be high or low. And if I input something into it, the thing I input can only be high or low. And I can only tell whether it's high or low. But these 6 pins in the bottom left of the board, labelled A0 to A5, they can read up to 255 values. So they are much more sensitive. The pins on the right can do 2 values. The pins on the left can do... I think it's 255. It might be 1023. I'm not sure, but doesn't matter. They can do multiple values, and we need to read multiple values from that potentiometer. So let's pick a pin. Let's go for A2. A2 is a nice pin. I'm going to take this middle pin from my potentiometer, and I'm going to stick that in, let's say, A2. Stick it in there. Let's make that pink. There we are. So when I finish writing the code, we should have it that when I turn this potentiometer, it makes the LED blink faster or slower depending on how much I turn it. So let's go into code. What do we need to do? Well, we need a variable. And this variable is going to store how much the potentiometer is turned to, what position it's turned to. So let's go to variables and let's create variable. And I'm going to call this, let's just call it value. Let's be boring. So what I need to do is I need to set the value to something. What do I need to set it to? Well, I need to set it to whatever pin A2 is sensing at the time. And what is pin A2 sensing? Well, if we go to input, we can read analog pin. Stick that in there. Read analog pin A2. And that should work fine. Let's make it stick part of our repeat. So let's put it in our top of our repeat block. Rather than 10 times, let's just put this to, I don't know, 10,000 times, 100,000, let's have 1,000,000 times, just for fun. So we're going to read the analog pin. But how do we weight however much that is? Well, if I go to variables, I can see that value is now stored. And I can drag this in to the weight blocks. Okay, let's give this a go. Let's run that. Let's start the simulation, minimize the code. We can see our LED is lit. Let's change the potentiometer. Interesting. Nothing's happening. So what do we do as computer scientists when nothing happens, or we can't tell what's going on? Well, we debug things. So I'm going to stop the simulation, and I'm going to go to code. And what Arduino has is a very good debugger called the serial monitor. And this allows us to monitor values. And all we have to do is we have to print those values onto the serial monitor. So if you go to output, and the second from the bottom says print to serial monitor. I'm going to grab that, I'm going to stick it straight underneath value. But what do I want to print? I don't want to print hello world, I want to print the value. So inside that bubble, I'm going to grab from variables the value, stick it in there. So let's see the simulation. Let's press start. Now we need to open the serial monitor, which is at the bottom along here. So if you click that, it tells us the value of the potentiometer. And if I minimize the code, let's drag that out of the way and get the code back open. Let's see what happens to the serial monitor when I change the potentiometer. Oh, it's gone up to 20. See, that's where our problem is. When we changed it a little bit, it suddenly went up to 20 seconds. So that meant we had to wait 20 seconds for our LED to turn on and off, which obviously isn't great. So let's change that to a smaller value. So I'm going to stop the simulation. Let's change this drop-down arrow. Instead of being seconds, we're going to have it as milliseconds. And the same for the bottom one. So even shorter than a second. Let's press start. Can we see our LED is now blinking? And that the value of the potentiometer is 307. Let's turn that up. It's now 716, and we can see that the LED is blinking a lot slower. Let's turn it way down. Let's change it to 0. That's going so fast that the LED is not even bothering to light up. Let's turn it up a little. 205, there we are. So the LED is blinking every 205 milliseconds. So that's it for now. We're trying something a little bit different this code club. We're going to have a little bit of a break now so you can experiment with Arduino. Will be available in chat for if anyone needs a hand with that. And then when we come back, we're going to be doing some more breadboard based kind of things. So without further ado, see you in a certain length of time. Not sure what that length of time is, but see you then.